Systems 2.9, ready, set, go. So, these first ones are just review of solving equations, which is a big part of helping us with systems. So, I've got r minus 5r equals negative 4r. So I want to get the r's all together, right? So r minus 5r would be negative 4r. Now you've got negative 4r equals negative 4r. So my question is, if I choose a number for r, are we always going to have the same answer? Well, yeah, because we're multiplying everything by negative 4. So when you have this situation, this is kind of with the systems when you have infinite solutions. It's basically what you have, okay, except they say all reals. Because it doesn't matter what number I pick, every single number would work in question number 1. Question number 2, we can combine the 5m and the 4m to get 9m. Plus 1 equals 1 minus 3m. Then we subtract 1 from both sides, add the 3m to both sides. Separate those, or cancel those. 1 minus 1 is 0. 9 plus 3 is 12m. Divide by 12. 0 divided by anything is 0. So 0 equals m, which is fine. We can have that. Not a problem. Okay, number 3, we can start by distribution or by division. Doesn't really matter. I like to start these ones by division. We get negative 5 plus 3n equals 91 divided by 7, 13. Then we add 5 to both sides. 3n equals 18. And we divide by 3, and you get n equals 6. Okay, 4, same idea. We can divide by 5 first. That's one way. We'd end up with 2v plus 1 equals 5 goes into 8 once, 17. Subtract 1. We get 2v equals 16. Divide by 2. We get v equals 8. The other way to solve this one would have been to distribute. You would have got 10v plus 5 equals 85. Subtract 5. 10v equals 80. Divide by 10. And v equals 8. Same thing, right? Because it's the same answer regardless of how you solve it. Alright, so now we've done all 3 of these problems before. However, we did them with substitution. Okay, now it wants us to do it with elimination. That new method. Okay, so when we look at this, we are trying to decide how we can get rid of one of our sunglasses or shorts. Okay, so I've got 2 glasses here, 1 here, 1 pair of shorts here, 3 here. So a few different methods I can do, and they both have the same price, right? Well, I want to get rid of the glasses, but if I get rid of the glasses, I still have 1 pair of glasses left, right? So why don't we double? Let's say we bought twice as much on this bottom one. So instead of just $50, we spent $100, because that's 50, right? We bought 6 pair of shorts and 2 pair of glasses. Well, now I know that these 2 pair of glasses and these 2 pair of glasses, and then there's 1 pair of shorts here, right? 1 pair of shorts here. So if I take all of this and take out the same amount here, I know that what's left over is going to make up the difference here. Difference being $50, right? So I know that I've got 5 pair of shorts left over. And that is equal to $50. So each pair of those shorts has to be 50 divided by 5, $10, right? So a pair of shorts is $10, which if that's the case, if that's $10, we'd subtract it from 50 to get 40. The glasses, 40 divided by 2 would give us, I know those are awesome glasses, aren't they? Would have to equal $20. Alright, let's take a look at this one. Nadia and Peter visit the candy store. Nadia buys 3 candy bars and 4 fruit roll-ups. So, let's make our candy bars. So she's got 3 candy bars and 4 fruit roll-ups. And I don't know why I've always think of fruit roll-ups as being red. Okay, 4 fruit roll-ups, and it cost her $2.84. Well, Peter also bought 3 candy bars, but he can only afford another fruit roll-up, and his purchase was $1.79. So using this new method of elimination, do I have something I can eliminate? Yeah. We've got 3 candy bars and 3 candy bars. We've also got 1 fruit roll-up. So, if I think about this, I know that this much has to be the $1.79, right? So if I eliminate it, then basically the 3 fruit roll-ups have to be the difference in the price. Which, if we figure that out, it's $1.05. So I know that with 3 fruit roll-ups, it's equal to $1.05. So if I divide $1.05 by 3, we'll figure out what 1 fruit roll-up costs. So it goes into 10 3 times. You get 9 minus, decimal goes up there, 1, bring down the 5. So I know fruit roll-up is 35 cents. So if a fruit roll-up, which we said was 35 cents, okay, so going back to this, I now know that that fruit roll-up cost me 35 cents. So if I take 179 and subtract the 35 from it, we get 144. But these 3 are going to be equal to 144. So what's $1.44 divided by 3 for our candy bar? Well, into 14 it would go 4 times, and we get 12. So 2, bring down to 4, 3 goes into 24 8 times, so 48 cents. So candy bar is 48 cents. And that's how we use that new process of elimination to figure that out. Alright, chickens and cows running loose. The farmer has 100 heads, 270 legs. So last time we made some equations out of this, because it's too hard to draw that many things. Okay, so chickens we'll call X, cows we'll call Y. So I know that I have 100 heads. So if I add the number of chickens and the number of cows, it's 100. So 270 legs, I know a chicken has 2 legs, a cow has 4 legs. So I know that's 270. So it's kind of like this one. Okay? What did we have to do here to get them matched up? We had to double one of our purchases, right? So in order to get this X to be the same as this X, we could double everything, right? Times everything by 2. Then I could say, well, I can eliminate those, right? Because 2x, and if I subtract 2x, that would be 0x, which just disappears to 0. And then 2 subtracting 4 would be negative 2y. 200 subtract 270 would be negative 70 divided by negative 2. You get y equals positive 35, which tells us how many cows there are, right? There are 35 cows. Now, if I know how many cows there are, we look back at this x plus y equals 100. Well, if I know that that's 35, we just have to subtract it from 100, right? To get chickens are 65. And that's how we'd use that new process for them. Alright, a little bit of graphing just to finish us off. Remember, if it's in standard form, what we typically like to do is to turn it into slope-intercept form, first by getting the x term on the other side, Can't combine it with the 4. Then we divide everything by the coefficient of the y, the number in front of the y. So I end up with negative 1/2 x plus 2. Up to positive 2, down 1 to the right 2, down 1 to the right 2, down 1 to the right 2 because it's negative, or up 1 and to the left 2 because it's negative. And there's my line. The other way we could have dealt with this was with the y and x-intercept. We could have said, well, to get the x-intercept, we know the y value has to be 0. And you end up with 2 times 0 is 0, 0 plus x is just x. So you get x equals 4, which would have been that point. Then, to find the y-intercept, you would have just made the x 0. So you would have got 2y equals 4 divided by 2. Y would equal 2, which would be the y-intercept. From there, you can see that slope if you really wanted to find another point, or you could have just graphed it. Okay, number 8 now, we've got an inequality. So remember, the first step is just graphing it as if it were an equation. Y-intercept of 3, slope of 4 over 3, so it's positive up and to the right, up 4 to the right, or down 4 to the left 3, and down 4 to the left 3. Okay, then we have to decide if it's solid or dashed. Solid being less than or equal to or greater than equal to, so we can look at ours and know it's dashed. So I draw a dashed line. Then I have to remember where to shade. I either shade over here or over here. So pick a test point. 0, 0 is a great one. Plug it into our inequality. 0 for y, 0 for x. 4/3 times 0 is 0. 0 plus 3 is 3. Is 0 greater than 3? Nope. So I have to shade the other side, because 0, 0 is not an answer. Alright. Okay, then the last two, both systems. So another way to solve systems, right? Graphing. Now, could I use substitution? Yeah, of course I could. Could I use the new one? Yeah, you betcha. Okay, I'll show you both. Or actually, I'll show you all three. Okay, but we'll do it on question number 9. So 10, I'm just going to graph first. So, -2, -2. 5x, so think about 5 over 1, so up 1, 2, 3, 4, 5 over 1. Okay, pretty much all I can put on this graph. Second one, +4. Slope of -x, that's like -1 over 1, so down 1 to the right 1, we can see exactly where they intersect. Okay, right there. So our answer is 1, 3. Okay, now if we look at the other one, we can graph it. -4, -3 over 1, so we go down 3 to the right one, or up 3 to the left one. Draw all my points. Okay, +2 and +3, so up 3 to the right one, or down 3 to the left one. And I can see where they intersect, right? Right there at -1, -1. Well, we could have also done substitution. Because I know that this is equal to y, I just replace this y with this. So I get -3x minus 4 would equal 3x plus 2. So I could have added 3x to both sides, giving me -4 equals 6x plus 2 subtract 2. -6 equals -6x, or +6x, divided by 6, and we would have got -1 equals x, okay, which matches up. Then plug that back in, substitute it back in for the x. -3 times -1 minus 4. Negative times negative is a positive, minus 4 gives us -1 again, our y value, okay, because you're going after the same thing. The last way would be that new method that we just have been starting to talk about, the elimination method. I believe it's also called linear combinations, if you were curious. So for that one, y equals -3x minus 4, y equals 3x plus 2. Well, then I could have said, okay, my x's are exactly the same, except one's negative and one's positive. So if I added them, negative 3 plus 3 would give me 0x, right? Negative 4 plus 2 would give me negative 2. 1y plus 1y would give me 2y. Well, 0 times x is just 0. 0 minus 2 is negative 2. So 2y equals negative 2. Divide by 2, I get y equals negative 1. Then I just pick one of my equations and say, well, if y is negative 1, what is x going to be? And then you'd solve for x. Which, pretty obvious to see, x equals negative 1. Same answers using 3 different methods.